Hello, my name is Jiwon Baek, a chemical engineering student, and my major field is energy. The topic of our presentation was optimizing agreeable takes with a prism. And today I'm going to talk about our CDP1, which focuses on finding the optimal prism design. Before we start, let me briefly introduce the outline of my presentation. First, I will talk about the climate crisis, and I will tell you guys what agreeable take is. Then I will move on to our main topic, prism solution, and our team's key idea. Then I will show you some experiments and results. Finally, I will tell you the conclusion and the future impact. In July 2023, the UN chief said the era of global warming has ended. The era of global boiling has arrived. To stop the rising temperature, we need to reduce fossil fuel and increase the renewable energy such as wind power and solar power. However, building more solar panels in Korea is not easy because about 70% of the land is mountain and much of the rest is too expensive or environmentally sensitive. So, a new solution is agrivoltaics. Do you guys know what agrivoltaic is? The word agrivoltaic comes from agriculture and photovoltaics. It means installing the solar panels above the farmland, so we can produce both electricity and crops at the same time. This idea comes from the concept of solar sharing. Okay, now let me talk about some advantages and disadvantages. Let's look at the advantages first. It can protect crops from the rain, snow, and strong wind. Then it can reduce heat and water loss. Finally, the farmers can get an extra income from selling electricity. But there is a big problem. The panel is blocked around 30% of sunlight, which can reduce the crop's growth. So our team started to thinking hard to solve this shading problem, and then we came up with an idea. Let's use prism. By using prisms, we can refract the light into the shaded reed. But then we thought, prism and solar panels, how do we even combine them? Honestly, we don't have any idea. We didn't know what materials to use or what shapes would work best. So we started from zero and did several experiments to find the optimal prism design. First, we compared the materials, acrylic and optical glass. By using ray optics simulation, we checked the refractive index. First, the refractive index of acrylic was 1.49 and the optical glass was 1.7. This means optical glass can spread light more effectively than acrylic. Next, we focus on the shape of the prism. We tested several prisms like equilateral, right-angled, square, and even pentagon prism. And after checking their light refraction, we decided to focus on two shapes of prism, equilateral and right-angled. We made a small solar panels and tested both two types, and interestingly, right-angled prism showed a lower shading rate, about 25.3%, while the equilateral was 27%. So it means the right angle prism was the most effective in reducing shadow than equilateral prism. In conclusion, to optimize your revoltatic systems, we found that the optimal prism should be made of optical glass which has a high refraction index and a right angled shade prism which gives a lower shading rate. Our project is still in an early stage, but prism-based agrivoltaic shows a strong potential for the coexistence of agriculture, agrivoltaics, and an energy. That was our project on optimizing agrivoltaic with a prism. Thank you for your attention, and if you have any questions, I'll be happy to answer them. Thank you.